Let's talk about the dimension of a vector space. Let V be a vector space. If a basis for V has n vectors, then every basis for V has n vectors. And we say that the dimension of V is n, or we might symbolize in this way, write it in shorthand. Any set in V with more than n vectors, that's going to be linearly independent. Any linearly independent set of n vectors in V is a basis for V. Any linearly independent set of fewer than n vectors in V can be expanded into a basis for V just by adding some extra vectors to it. Let's talk about the dimension of a vector space. Let V be a vector space. If a basis for V has n vectors, then every basis for V has n vectors. And we say that the dimension of V is n, or we can write it in shorthand in this way. Any set in V with more than n vectors is going to be linearly independent. Any linearly independent set of n vectors in V is a basis for V. Any linearly independent set of fewer than n vectors in V can be expanded into a basis for V. Find the dimension of the null space of A where A equals this matrix. We know how to solve that. We're basically trying to solve AX equals 0. The reduced row echelon form of this matrix looks like this. So our first two equations are going to be x1 minus x3 minus 3x4 equals 0, x2 plus 2x3 plus 4x4 equals 0. Again, copying them from the previous slide. This is what we have. And then if we move the free variables to the other side, we get this. Therefore, the solution is going to be x1 equals x3 plus 3x4, x2 equals negative 2x3 minus 4x4, x3 equals x3, x4 equals x4. That's what we do with free variables. We can pull out an x3 and an x4 and rewrite in this way. So it's going to be x3 times 1, negative 2, 1, 0, plus x4 times 3, negative 4, 0, 1. And if we can write all the solutions to AX equals 0 in this form, that means the basis is going to be these vectors, 1, negative 2, 1, 0, 3, negative 4, 0, 1. That's a basis for the null space because every solution to AX equals 0 can be written as a linear combination of those two vectors, and those two vectors are linearly independent. So this is the basis. So the dimension of the null space is 2. The dimension of the null space is the number of free variables in the solution to AX equals 0. That's another way to look at it. We have two free variables, x3 and x4. Find the dimension of the column space of A. Well, the pivot columns of A form a basis for the column space of A. The reduced row echelon form is this. We can see that the first two columns are the pivot columns. Okay, we got this one and we got this one. Thus, a basis for the column space of A is going to be these two columns. Again, a basis for the column space of A is the pivot columns, not of the reduced row echelon form of A, but of the original matrix A. And so the dimension of the column space of A is 2. The dimension of the column space is the number of pivot columns in A.